There we go. So we have an intersection. The and probability was the probability of A and B happening at the same time. We're going to get into that more today. Here is what we call the union. The or looks like a U. The and looks like an upside down U or a small n. Remember, my key was A and B. If you say it fast, sounds like N. A and B. A and B. A and B. And then we have the not probability. The probability of not getting A. And I want to follow up on that last one, if I can. So let's add this here. The probability of not getting A is equal to 1 minus, so add this into your notes, 1 minus the probability of A. Okay? So what are you talking about? Well, let's think about this. If you are the type that believes there are two sexes, okay, boys and girls, male, female, okay, so the probability of not being a male would be that you're a girl, right? If you're talking about probability, the probability of being a boy or a girl means probability of 1. That's 100%, right? So the probability of not being a girl would be 1 minus the probability of being a boy. Okay? Let's say, I don't know, how many girls and boys do we have in here? That seems too complicated, but that's what it means. All right, let's get to some of these examples. All right. Your teacher needs to pick a student to deliver something to the office. Use the students in your classroom to help you answer the following questions. Well, I guess we're going to be counting anyway. All right. What is the probability that the student chosen is wearing a black top and is a junior? Okay, so this is the and statement. Looks like an N, black top and junior. First of all, how many people do we have in here right now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we have 22 students total in our classroom this morning. If I'm trying to find the probability that someone is wearing a black top and is a junior, I need that total 22. Where is that going to go in my fraction? On the bottom. Okay, that's not too bad. All right, where are my juniors? Raise your hands. Raise them high. 1, 2, 3, 4. I have 4 juniors. 1, 2, 3, 4. That's it? 4 juniors. Okay. And of those 4 juniors, can you stand up for just a minute? I know. We need to see if they are also wearing a black top. I would say yes. Oh, we have 5. Okay. So I would say yes, 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 and no. All right, thank you. You can sit down. So I need the probability that someone is wearing a black top and is a junior at the same time. So what is that number going to be? We had 5 juniors. You might want to write this down over to the side. 4 out of those 5 juniors had black tops. So that means this 4 is going to go over here. So it's going to be 4 out of 22. Because we had to have both of those things happening at the same time. Okay? Any questions about that one? Let's take a look at letter B. What's the probability that the student chosen is wearing a blue top or a green top? blue top or a green top. Okay? So, how many students do we have total again? 22. So, finding the denominator is usually not as difficult as finding the numerator, the top. Now, if this is a blue top or a green top, that means I want everybody with a blue top plus everybody with a green top, but there might be somebody that has a blue top and a green top at the same time. Maybe they have both colors on. Okay? So minus anyone with a blue and green top. Okay? So if you have a blue top or a green top, can you please stand? Come on. Kenya, stand up. So out of our class, I would say we have 3 people with a blue or green top. Now, take a look at them. Do any of them have green and blue at the same time? What would you say? Yes or no? This is the active participation. Do we have anyone with both? No. Thank you. You can sit down. So, blue tops, we had 3. Green tops, we had 0. Minus, we didn't have anybody that had both at the same time. So 3 plus 0 minus 0 is 3. That means this answer is 3 out of 22. That is the word or. Or looks like the U. Okay? So this is and looks like the small n, or looks like the U. All right, letter C. What is the probability that the student chosen is not a sophomore? Not a sophomore. You tell me, what's my bottom number going to be? 22. We still have the same students in here, right? So 22 is going to go on the bottom. And not a sophomore. Did we have something about sophomores yet? We did not. So where are my sophomores? Raise them high. Raise them high. So 1, 2, 3. Marvin, are you a sophomore? 10th grade? Okay. 1, 2, 3, 4, 5. What are you? Are you a junior or sophomore? Are you a sophomore? Lens. You're a sophomore. Guys, we try to be accurate here. Okay. 1, 2, 3, 4, 5, 6. Yes. Sophomore. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, yes, sophomore, 17. Okay, so we have 17 that are sophomores. That's not what we're looking for, though. We want who is not a sophomore. Okay? Well, if I had everybody in the whole class, that would be 22 out of 22. That would be one whole, right? So I am going to take away, to get the not sophomores, I'm going to take away those that are sophomores, which is 17 out of 22. So what is 22 minus 17? It's 5. Okay, so not a sophomore means there are 5 out of 22. So this is not a sophomore. Okay, not a sophomore. So if we said how many were not freshmen, we would take 22 minus however many freshmen there are. I don't think there's any freshmen in here. So not a freshman would be 22 minus 0, which is 22. So to figure out the not, you take the full number minus how many there are of that. Kind of opposite, right? Does that make sense? Just say yes. Head nods are big or no. Okay. All right, let's get to the bottom. This is the fun part. I think it's fun. Well, yeah, you're a math teacher. All right, this is called a two-way table. Two-way table. It says, a group of students were asked their favorite sport to watch. Use the table to calculate the following. So we have males and females, okay? We also have baseball, basketball, and football. We have total numbers in the last column, and we have total numbers in the last row, okay? So, and this number down here in the bottom right corner, I call this the total. And I've made that up myself, okay? That is the number of total students that were surveyed, all right? Because I call it the total because that is the total number of people that you have taking the survey this way that are males and females, and it's the total number that say their favorite sport is baseball, basketball, or football, okay? So I want the probability that someone said baseball was their favorite sport to watch. I don't care if they're male or female. I just want to know that baseball is their favorite sport. Okay? So I look at baseball here, and you go down to the bottom for the total of baseball. All right? So go to baseball, which is right here. Go to the bottom. This number becomes your numerator because that is the total that like baseball. But I need to put that over everyone that was surveyed. So I'm going to put that over the total of everyone that was surveyed, which is going to be 100. Now, sometimes we're going to say you can leave it like that, but those are both even numbers. So I know I can divide that and simplify. So simplify if possible. Oh, greatest common factor. They do both divide by 2. I'm going to use that, but we're going to see that's not enough. 36 divided by 2 is 18. And 100 divided by 2 is 50. Wait a minute, those are both even also. So we can divide by 2 over 2 again. 18 divided by 2 is 9. And 50 divided by 2 is 25. So yes, we will take 36 over 100, but this is the better answer. Is everybody with me? Just say yes. Guys, I'm telling you, head nods. Yes, no. If you go like this, I'm going to wonder about you. All right. Here we go. Let's look at the next one. I'm going to erase mine just so it's a little bit easier. Okay. This says the probability of football and male. Football and. This is the and. Remember, football and male. This means they have to happen at the same time. Okay? So I look for football, which is in this column, and I want to look at males, which is this row. You might remember the and is called an intersection. Okay, intersection. Well, where do they intersect? Right here, at the intersection of males and football. So this means my numerator is going to be 20 out of, how many were surveyed altogether? 100. Okay, both of these numbers end in a 0. That means they're divisible by 10. So 20 divided by 10 is 2. 100 divided by 10 is 10. Up to 10. Both of those are even, right? And it's okay not to get the greatest common factor right away. Divide both of those by 2, and you get 1/5. So 1/5 is the best answer, but I would also take 20 over 100. Why didn't you just take 20 over 100? Well, because you know it can be simplified. So football and male, you find where they intersect when it's an and statement. All right? And here's the last one. This is the probability of basketball or female. Basketball or female. So we want the probability of all that like basketball, plus we want all the females, okay? Because you can like basketball and you can be female, or, I should say or. But some of those are going to be counted at the same time. So then we have to subtract the probability that you like basketball and were a female at the same time. You're like, what? All right, let me show you. So the probability of basketball or female. Here's my basketball right here. Okay? That's 31. And we're talking about just the numerator right now. Just the numerator. Plus, I need the probability of all females. All females. That's going to be 52. Now, take a look. How many were both basketball loving people and female? 16. Well, we have counted these 16 people twice. We counted them as females in that total, and we counted them as people who enjoyed watching basketball. So we can't have them in there twice. That's inflating and making our numbers bigger. So then we have to subtract what they have in common, which is that 16. So we're going to subtract that 16. Does that make sense? A little bit? So when I add this together, use your calculators. 31 plus 52 is 83, and 83 minus 16 is going to be 67. That's my numerator. Over how many total? 100. It's always 100. Now, 67 over 100. Can I simplify that? I don't think so. So this is your final answer. Okay? All right, so let's do a little bit of review. If I have an and statement, whoops. If I have an and statement, like here, looks like a small n. That's where you look at the intersection, okay? It has to be both at the same time. If I have an or, that's a union. I want to have this and I want to have this, but if they have something in common, I can't count them twice. So I subtract what is common to both. And that's how you get your numerator. All right, let's keep going. You guys are doing great. Let's go to the top of the next page. So, a survey was conducted to find the most popular ice cream flavor. Use the table to answer the questions. So, we got children, teens, adults. We got chocolate, vanilla, and neither. Do you notice or see that anything is maybe missing? Is anything missing from this table? Total, yes. If you look in the last column, that's neither. But guess what? We need a total over here in the last column. So we need to add that up. Well, how do I find the total? You need to add up everything in the row. So, children, let's see. We had 40 children that liked chocolate, 22 that liked vanilla, 15 that liked neither. If I add these all together, 40 plus 22 plus 15, I get 62 plus 15 is what, 77? Check my math, is that right? Okay. Teens, how many total teens did we have? Well, 12 plus 16 plus 45, 28 plus 45. That's 73? Yes? Okay. How many total adults did we have? 55 plus 54. That is 109 plus 10 is 119. That's 119. That's adding 55 plus 54 plus 10. And then the last one, 107 plus 92. That is what? 199 plus 70. What is that? 169? Check my math. Oh, yeah, 269. Thank you. Yes, 199, 269. All right. So now we can answer A. How many people were surveyed? That's right. That is the what I call the total. That's always going to be in your far right corner. I call that the total. Okay? Now, we want to find the probability, remember, probability that someone likes vanilla as their favorite ice cream. Write down your answer. Let's see how we do with these. Probability of vanilla. Actually, time-wise, I probably should keep going. So we look at all vanilla, which is 92. That's my numerator. And what's that going to go over, class? 269. Yes, this is the active participation. If you are actively participating, you're going to learn a whole lot more. All right. Let's go to E. I know it's E, but let's go to it because it's next. What is the probability that they did not like either chocolate or vanilla? Well, let's see. Neither. Find that total for neither. That is 70 over 269. And these, it's kind of hard to tell if we could simplify these, so I'm not as worried about that right now. All right, let's go to letter C. Find the probability that someone does not like chocolate. Does not, this is not, chooses chocolate, right? That little tilde symbol. So I need to take 1, which would be 269 over 269, minus the probability that someone does like chocolate. Okay? So how many like chocolate? It is 107. So 269 minus 107 over 269. So 269 minus 107. Let's see, that's going to be a 2, a 6, and a 1. And it's all over 269 because we know when we add and subtract fractions, you keep the same denominator. So this is your answer. So let me repeat that one. When you are trying to find not, you put the total number over itself and you subtract the probability that whatever is the positive of that. Okay? So this was the probability they did like chocolate, which was 107. Because you either like chocolate as your favorite or you don't, right? Yeah. All right, let's take a look at F. Find the probability that someone was a child in this survey. Okay, so we need to find all the children. That would be, what's that number? All children? 77 divided by the whole survey, which is 269. Excellent. All right, here come the hardest ones. Find the probability. Wait a minute. Is that an and or an or for letter D? And. It looks like an N. So this is chocolate and adults at the same time. At the same time. All right. At the same time. So I'm going to erase some of these other ones just so you can see. Chocolate. Here's chocolate. Adults. Over here. How many like and are chocolate, like chocolate is their favorite, and are adults at the same time? 55. Very good. It's where they intersect. So that is 55 over 269. Okay, so an and statement at the same time. All right, here's probably the hardest type. So I'm going to erase this. Vanilla or children. Vanilla or children. Here's vanilla. Here's all my children. Ooh, that was a soap opera, wasn't it? All my children. All right, so I need all vanilla. This is or. We want as many as we can get. It's a union. So vanilla, which is 92. This is just the numerator. Plus all the children. How many children? 77. But some of those children that liked vanilla were counted twice. So I need to subtract 22. I need to subtract this amount because 22 of those people were counted twice. So 92 plus 77 is 169 minus 22 is going to be 147, check my math, out of 269. Does that make some sense? So if it's or, you're going to subtract. If it's an and, it has to be the same at the same time. Oh. Questions on that? All right, let's go to the next page. Really quickly. I know we're about to run out of time. Darn it. All right, just listen. I'm not going to do anything, but this On this page is called a frequency table. How often something happens. Okay? We are going to get into that tomorrow. But let me also tell you, homework number 1, due on Friday. You should be able to get a good start on it. Not all the problems. You're not going to be able to do all the problems. But you can look at it, pick the problems that you think you can do. All right? Tomorrow we will work on frequency tables and fundamental counting principle. You're going to like the fundamental counting principle. I guarantee.